afternoon, everyone. Welcome to the last Conversations About Carbon session for the semester. Today we have Sandra Campos-Diaz joining us. Sandra currently teaches science to high school students in Madison, Wisconsin in the Metropolitan School District. She has been engaging students in learning about a range of environmental topics and continues to be part of her motive for teaching. She has used the People and Ecosystem Watershed Integration in her classroom to model and evaluate trade-offs between crop yields, nitrous oxide emissions, and nitrate leaching from land uses. So I'm going to kick it off to Dana and Sandra.
Awesome. Thanks so much, Kalina. My name is Dana Schweitzer. I'm the Deputy Director for Regenerative Agriculture here in the Bioeconomy Institute at Iowa State University. And we are delighted to have Sandra with us today for some perspectives on, high school education around STEM and climate change. So Sandra, we're so happy that you're here with us today.
Thank you so much. I feel very honored to be here and to represent high school education. Thank you so much.
Yeah, awesome. Well, I think we'll jump into our questions. Just thinking about, as you're wrapping up the semester, I know your students are probably excited to be getting ready for a winter break, maybe. I hope you are too.
Today is actually our first day of the winter break.
Is it? Okay, fantastic. Yeah, fantastic. It is for my kids as well, and you can tell they're very excited. So coming into your classroom, what information do your students typically know about greenhouse gases, energy, food, water quality? What's their knowledge base when they're starting in your class at the beginning of the year?
Students definitely know the major details about greenhouse gases. They do for sure recognize carbon dioxide as one of the greenhouse gases. Some students do know about methane, and nitrous oxide is the least greenhouse gas that is known by students. Because science education is is like general chemistry, general biology, general life science. Students typically do not know about food and food production systems. They may get a lesson here and there, but there's definitely not a deep dive into food production.
Got it. Interesting. And is there any of those areas that you find they're maybe most curious about?
I know it's students are right now mostly interested in bioengineering.
Okay.
That is like one of the cool sciences
Sure.
currently.
Yeah, interesting. I realize I got a bit ahead of ourselves. Can you tell us which courses, like which subject matter you're typically teaching, whether that's every year or like in a rotation over a number of years? Which subject areas are you leading your students in?
For the past 4 years, I've been teaching biology, chemistry, and a course called Unified Science.
Oh, okay. Can you say more about the last one?
And that one is more like different topics. Like there's a mini biology unit, a mini chemistry unit, nuclear energy unit. Most of the concepts are about energy.
Okay, got it.
Including mechanical energy.
Sure, yeah, very interesting.
But this year, I'm sorry. This year I've been teaching chemistry. That's the only subject I've been focusing on this year.
Okay, got it. Yes, your earrings are like very on point for that. I love it.
Yes.
Fantastic. Okay, so during your class, whether it's chemistry or one of the other topics, how are you helping your students approach that knowledge gap, maybe helping them grasp some of those complex topics? Like you mentioned, nitrous oxide is, there's a lot of complexity there. So how are you helping them like navigate through their journey learning about these topics?
Yes, that topic is so complex, and I think the key is to approach it step by step, and to allow students to give students opportunities for hands-on learning. I think it's very important for students to be involved in labs where they can be collecting data, where they can see those patterns through the data they collect in the labs. And I think that's the key for students to grasp the big picture by looking at the small details.
Okay.
And giving them the time to process those small details and building each of the concepts to get to the bigger concept. It's especially important because the scientific vocabulary is like so heavy.
Sure.
They have to really understand those, not only the vocabulary, but the concepts. They're so abstract. So it's very important to make the connection between the abstract and what can be seen.
Sure. Yeah, I think you make a great point that there's many aspects of science that are jargon heavy. I mean, it's the same in lots of specialties. So from your experience, sort of helping them connect with the applied activities is then maybe going to help them sort of ladder into understanding some of those more abstract concepts.
Definitely. The best way for students to learn the vocabulary is to have the experience using it like a scientist would use it.
Sure.
I personally do not like giving students definitions. I know it's not going to make sense. They have to do the learning activities and they have to be using those terms constantly for them to really, when they're using them, they really know what they're saying, and for them to feel comfortable talking about those scientific concepts.
Yeah, that absolutely makes sense. And remind me, are you instructing students in both English and Spanish?
I do have one class that is a ESL chemistry class.
Okay.
Students in that class are at the intermediate or advanced English level. Students usually exit ESL shelter classes after their advanced level. But I do use Spanish, but the class is in English. So I have to be teaching both science and to some extent English. So they are learning English while learning the chemistry.
Sure.
And most of the students are Spanish speakers, but I do have students that speak Wolof. And I cannot teach in Spanish, but I will talk to students in Spanish one-on-one, but the whole class instruction is in English.
Okay, got it. Yeah, just thinking about the complexity of helping them navigate not only some of the scientific jargon, measurements, and then alongside helping to navigate, the language barrier as well for some of them. I mean, that's a lot of complexity.
It is so much. And I feel like for those students that are in those classes where they're learning the subject and the English, that's a lot for them, a lot of cognitive demand, both cognitive and linguistic demand. I really feel very proud of them. And what I've learned by teaching those classes is that teaching the academic language, the scientific language, is often much easier in those classes than in the non-ESL classes, just because they have to rely on that academic language.
Sure. Yeah. That's interesting. Wow. Okay. So one of the things that we got to collaborate on these last 2 summers is you had an opportunity to connect with our team here that's working through both landscape and other biological modeling projects, and sort of build a module to help your students learn more about what's happening with different conservation practices in the landscape. So we know that learning module was one of the things that came out of your research experience with the team. And whether that's an example that you can use or not, I'm curious, what's an example of an activity or a lab experiment that you're using to help those students really get into the details and understand applied aspects that they can then help to understand the more abstract concepts?
It's been great to have had those 2 summer experiences, because I've always been interested in projects connecting it to the real world, but it's often so difficult to do that in the high school lab. And these experiences and working with the sea change team at Iowa State and also at Penn State has really helped me develop those activities for, not just activities, projects for students. I would say that it's not just one lesson or lab. It has to be built up, right? It has to be a set of lessons and labs to help students really grasp the big picture, the big problem and potential solutions. Mm-hmm. I know that in the last project that I did, the first project that I did with the nitrous oxide emissions, the leaching of nitrate, and the trade-offs with the food production, doing the labs in the classroom. I can think of several labs that I did with different soils, mm-hmm. with like a sandy soil, a more silty clay soil, and having students run water through them for them to see the differences in water infiltration, mm-hmm. and doing a lab with a dye that would simulate nitrate was also very important for students to really see what could happen with nitrate as it goes through the soils into the groundwater and other waterways.
Okay.
And like those types of lessons that are focusing on smaller concepts at a time can then, I think, really help students once they got to using PEWI, sure. Because they had all of these smaller steps, smaller labs where they've been doing the learning by collecting the data and like really building that academic vocabulary and the conceptual understanding. By the end, I mean, I could see them easily using PEWI. And it also really helped that PEWI is a really easy interface for students to use. But they understood why they were using it and for what reason they were using it.
Yeah, that's fantastic. It sounds like, especially with the soil infiltration, like you've got some future hydrologists in your class, maybe?
I would say so, yes.
Good.
I was lucky too, because that cohort of students had been my students the previous year in a chemistry and in an ESL chemistry class, and we did explore water quality in depth, mm-hmm. Especially because it was the virtual learning year.
Okay.
And that was like the big topic that we focused on.
That's fantastic. So cool. Is there, when you're thinking through not only what you're doing to support your students, what are either highlights or maybe challenges that you've encountered when you're designing and implementing these learning modules, these activities?
I think I always look for resources online and talk to my colleagues. So I think one of the challenges is creating, like starting from scratch, right? Like if it's easy, it becomes easier if there are resources already that maybe I just have to modify, but it's definitely a challenge to create something from scratch, which is also very exciting. And I'm very fortunate to be working in a district that allows for teachers to be creative in creating a curriculum. Like we don't have a mandated curriculum. We have like a resource. We use resources. They give us resources like textbooks and online labs that we can use, but it is not mandated. And so I think we are very fortunate in this district to be able to use our creativity and also like working teams, sure. To create curriculum.
Yeah, that's fantastic. We are big fans of teamwork here in the Bioeconomy Institute.
I got to
Very cool.
experience that. I got to experience that when working with Dr. Lisa Schulte-Moore and Richard Magala. And yeah, it's great.
Yeah. I think it definitely lends itself to, advancing interdisciplinary science, no matter what level. Yeah.
Definitely.
Fantastic. Thinking about, talking about you being able to utilize that creativity in some of the curricula that you're designing, are there modifications that you think should or could be considered for high school STEM curricula based on your experience teaching these students?
Definitely. One of my roles is to work with my teams, to really have students that are language learners or that have that label as a language learner.
Okay.
And to really scaffold the curriculum, to break it down into smaller steps, to really move away as much as possible from lectures, and really give students those opportunities to do the learning through hands-on activities.
Got it. Do you find, especially for students at that age and grade level, are they more enthusiastic about things that are hands-on? I mean, are they maybe thinking that some of the abstract stuff is either overwhelming or maybe a little bit boring?
They're definitely excited about doing labs. I know that I've done units where there are limited labs, and students struggle the most with those. They definitely need those hands-on, those labs, and they really help them.
Fantastic. Yeah, that's what I would expect, and I'm so glad to know that they've got that opportunity to really engage with some of those things hands-on. Yeah, I think that's awesome.
Definitely. We just did a unit with the structure of the atom and nuclear fusion, and that's really difficult to bring into a lab.
Yeah.
Yeah.
Cool. All right. For those of us who are in attendance today, in a few minutes, we'll be ready to pivot to our Q&A. So if you have any questions for Sandra, please feel free to plug them into the Q&A down in the ribbon. We'll be able to see them there and bring them up and present them to her to respond. As you think about not necessarily other things, but as you think about, what your goals are within the course of your career as a teacher, are there things that you are most excited about as you kind of think about the possibilities? I mean, what motivates you as a teacher?
Oh, the possibilities are endless, I think. And one of the things that I really like about teaching is that there are opportunities for continued growth. Education, I think, is a relatively new field. So there's ongoing research, and so much more to learn about instructional strategies, about different approaches. And one of the things I am exploring more, that I'm wanting to explore more right now, is looking at the community where students live, so that to bring issues and also focusing on the positives of the community into the classroom, so that students can see the purpose more clearly. Sure. in the classroom. I am wanting to explore advanced placement courses for students that are language learners. I've been really fortunate to meet professors at UW-Madison that are working with students of color and teachers of students of color to give them to explore more opportunities. And through those partnerships, I learned about this advanced placement course that is very appropriate for students that maybe need a slower pace than traditional advanced placement courses, where they can be really successful and can also help them with their language skills.
Sure. Love that. That's fantastic. Yeah, I think it's such an awesome opportunity to integrate, as you first mentioned, not only connecting with what's happening in their communities to what it is that they're learning, but then being able to integrate like all of those pieces that inform their experience. That's really fantastic.
That's my goal.
Cool. I think that's an awesome goal.
Thank you.
All right. So we're ready to turn it over to Dr. Alexis Campbell for our Q&A. Hold on just a second. Alexis, how you doing?
I'm doing well. Thanks for allowing me to join in. Excited to hear more from you, Sandra.
Fantastic. All right. So I'm going to turn it over. Can you see the questions that are coming through the Q&A tab, Alexis?
Sorry, give me 1 second.
Yep, you're fine.
Okay. I see current questions, but I think I had submitted a few questions there and I don't have the past ones. Is there a way to see previous questions also?
That is fine. Go ahead and start with yours. And Kalina and I will feed through the rest that are in the queue.
Sure. So I'm excited to learn more about how your research experience over the summer has kind of shaped your overall idea about classroom teaching and content that you're bringing in. And so just curious if you could talk a little bit about that, and also if you've applied some of the techniques and how you worked through these research experiences and placing them then into the classroom, if that's transpired into other parts that you're teaching within the classroom.
For sure, yes. I think before the research experience, the approach that I took was to look at a unit and find places where I could have students do labs, but not necessarily be tied together into a project. And that's what I've been able to do after participating in this summer experience, is to, yes, continue to come up with those labs for students to do the learning, but in a cohesive way that ends with students looking at a bigger picture and doing a project.
Very cool, thank you. So this question comes from Dr. Robert Brown. He says, often the science of the environment focuses on the problems of climate change rather than the potential solutions. I realize that middle school and high school curricula focuses more on science than engineering. So I wonder if the students get much exposure to engineering solutions.
I think in the present, like lately, engineering has become more a more common part of the curriculum, because there's starting to be a bigger focus on STEM in general, but it's a smaller part of the curriculum still, I would say. Right, and I think it's because students have to be building up the concepts to be able to get to that part of the problem solution that is the focus of engineering. In addition to think about the resources needed for students to complete projects.
Thank you. So earlier you described the PEWI program. Can you give a little bit more detail about what that is and how you've used it?
Yes, for sure. Students were learning about water quality, about carbon sequestration and carbon dioxide emissions, about food production and how they're all related, and like the trade-offs that is present in food production in agriculture. I know that the capabilities of PEWI are much more than talking about water quality, emissions, and production. And in the project that my students worked on, we just focused on those three. But I know that it could be used for teaching about biodiversity, many different concepts.
Well, thank you. So has your work through these summer experiences, what you've been able to incorporate into your classroom, has that inspired any of your curriculum team that you're working with to think more creatively about what they're doing in the classroom as well?
I think so, yes. There was especially one team from my previous school, and we really got to work together as a team, and we developed this project around urban heat islands. And it did help that I had a colleague, one of my colleagues back then. She also participated in a research experience for teachers. So it definitely helped to have that mindset of what to create for students in a team, because sometimes it could be difficult if you have a big team, especially if it's a big team. It can sometimes be difficult to work towards a goal. But I think that having two people with research experience for teachers really helped us develop this project.
Cool, thank you. The next question is, it's very interesting that students come to your classes knowing about energy and greenhouse gases, but not about food production. Is this consistent among more urban and rural districts, or would students from rural districts have more awareness of science associated with agriculture and ag environments?
That's a really interesting question. I think I know that in my current high school, there's no class, like an agronomy class or animal science class, but I know that in smaller districts around Madison, even in the same county, that are in semi-rural areas, they do offer more courses that are related to agriculture. And I think it could be related to Madison schools being in an urban center, even though we are surrounded by agriculture. Like agriculture is huge in Wisconsin. I could say too, I'm sorry. I could say too, I'm sorry, like I could say too that the curriculum is focused on core subjects, which are physical science, biology, chemistry. And that way it's been taught, I think, historically is not interdisciplinary. So I think it's gonna take a lot more work and more convincing, or maybe just a change in how science education is thought of to make it more interdisciplinary.
Thank you. That makes a lot of sense. And so I think I saw a little bit about taking a phenomenon type approach. Is that right with some of the work that you've been doing in the classroom?
Yes, definitely.
And so is that, does that do anything or speak to bringing in a little bit more of the multidisciplinary nature of things? Or is that an opportunity to do that?
I think so. I think it's definitely, it can definitely lead to thinking about how smaller concepts are related, right? Because there's a phenomena usually don't happen on its own. There's several branches connected to phenomena. But I also think that it helps to think about that engineering aspect of it. Or for me, that's where my interest is, in thinking about, okay, so there are a lot of environmental problems, right? And it can be depressing sometimes. I think always, not sometimes, always. And I think the key is to think about the solutions. So approaching it as a problem solution pair.
Yeah, very cool. That makes a lot of sense. Our next question then is, how do student perspectives on climate change and the roles of ag, how have you seen that progress over the years?
Let me think. I don't know if I can talk about a progression. I know that students, once we start talking about food production and the environmental impacts, they're really interested. They're really interested about it, even if they don't have experience with gardening, for example. I know that in urban areas, there are community gardens, right? But even if students don't have that connection, they do understand that it's a challenge for society, and they do get interested.
Very cool. A lot of times I have seen with our students and scholars that work within the Science Bond program, they often come in like maybe in middle school, early high school, and very focused on thinking about ag as, oh, that's farming, and just kind of set it there. And so it's interesting to see that you have your students thinking about food production and other things, and that that often doesn't like connect right in the beginning, but then as they're having these experiences and what you're bringing into the classroom and other people's work, when they get to experience some of those things, that breaks down some of that barrier for it's just farming, right? And not thinking about it in all of what ag is and how that contributes to society. So very cool. Sorry. So next question is, how do you help your students explore the carbon cycle?
The carbon cycle can also is very complex, right? So I remember my first year teaching in my ESL biology class, and I did break it down into several lessons so students could see the big picture, because it can be very overwhelming when looking at the lesson in the textbook we were using. I knew we had to break it down. And I didn't have many labs from that first year. And I know going to the second year, it really helped to be able to use PEWI. Because in the past, I mean, all we did was looking at data, looking at interpreting graphs, looking at the patterns between carbon dioxide emissions through time and temperature, getting students familiarized with fossil fuels and the different carbon molecules and the transformations that happen. And I think it's very important for students to have more hands-on activities. I know that for my current chemistry class, we're going to be exploring carbon dioxide and the effects on temperature more in depth. And I'm very excited that I actually now have labs for students to collect that data and planning a small scale carbon sequestration project, where students can also like set up CO2 sensors, and they could see the differences in the lab.
Very neat. Can you talk a little bit more about what like a lab experience would look like, and when they're collecting data and what they would do with the data? Are they doing any statistics or looking at things? Yeah, really, just how are you analyzing? Take us through kind of what a lab is for a high school student.
I'm gonna say that we don't go that we could go that extra step to the statistics. I haven't yet. I try to keep it as simple as possible for students to be able to collect the data and look at the patterns. Look at the patterns and be able to make a claim using that data. One of the science and engineering practices is analyzing and interpreting data, but also constructing explanations. So what the students typically do after collecting data through a lab is look at find those patterns and make a claim that is supported by the evidence, and then looking at what the learning that has happened within a unit to construct an explanation to that claim and evidence.
Thank you. We have another question. It says, it's great that your students come to your classes with awareness of greenhouse gases and also climate change. Do you know, or to what extent are there also opportunities to teach and learn about climate change solutions?
Definitely, yes. I think in the Urban Heat Island project, we talked about potential solutions, including green roofs and more green spaces. In the project that my students did with PEWI, they explored the use of different crops and different land uses as part of the solution. And what have I had my students do? They explore solutions in transportation as well. And I remember giving students the time to think about, okay, so what are the changes needed in the community for some of those changes to be able to happen? A concrete example is cars. Students in high school are starting to drive. They're starting to get their driver's licenses, and they often work and save money to buy their first car. So I have them explore electric cars, hybrid cars, and I found this really cool website that shows the infrastructure for electric cars in the US. So it's a map, and they get to go to different cities and explore where there are charging stations. So I have students explore those things that cities need to really get at those solutions, right? Because yeah, maybe some of the solutions are here, but there are other things that we need.
Right, to be able to make them accessible to more people and usable. Thank you. So I think there's one last question, and I think it's a fantastic way to kind of round out our time with you today. and thinking forward or thinking in the future for the students that have taken your courses, are there students that have then expressed interest in exploring these types of questions as a part of their career? Do you know kind of fields that they're interested in studying for college or past that?
Yes, students have expressed interest in science for sure. And the specific fields range from marine biology to medicine to biotechnology and renewable energy for sure. And Madison does have a program. It's called Early College STEM Academy. So students can focus in a STEM career, including renewable energy, in their junior and senior year. And they actually take all of their courses in a community college. And it's great because it's free, right? Like if students know by the time they are juniors that they want to do a career in science, they can take this opportunity and they get dual credit. They get credit towards an associate's degree, as well as the credits for them to graduate in science in high school, from high school.
That's really great. So is that an early career, early college access program? Is that what they call that
Early
type?
College STEM Academy.
STEM Academy. Okay. So I think I have a graduate student that is working with me that came from Madison, and I think that she was a part of a program very similar, and maybe the same program that you're talking about. And just the way that she talks about how that changed her life is really, really it's very impressive and so exciting that you have that or the students have that as a part of something that they would be able to participate in.
That's exciting to know, and that's exciting
yeah,
have a student from Madison from that program.
Yeah, yes, for sure. She's doing her PhD in higher ed, actually, so it's very neat, and she wanted to study programs like that. So very cool. So Dana, are we to round out our time now?
Yeah, I think we've reached the end of our questions that attendees submitted. So thanks so much, everyone, for engaging in this conversation today. Thank you so much, Dr. Campbell, for walking us through our Q&A. It's fantastic to hear like the variety of experiences that these students are having and how they're engaging with the science. And Sandra, oh my gosh, thank you so much for everything that you do as a teacher, not only with your students in the classroom, but also thinking about how to support your fellow educators, in bringing these learning modules, to life. So yeah, just fantastic. Thanks so much.
Thank you. Thank you so much for the invitation. Nice to meet you, Dr. Campbell. And I feel very fortunate to have been part of meeting you, Dana, and Dr. Lisa, and Richard, and everybody in the team, Dr. Jim as well. And it's great. I think this is what I like about being a teacher the most, being able to continue my professional development, and because the science is going to continue to be changing. I get to be changing my teaching as well.
Yeah, fantastic. We love lifelong learners, and we're so happy that you were able to join us these last 2 summers. Well, thanks so much, everyone, for tuning in for Conversations About Carbon. This is a wrap for our webinar series for 2022. So thank you so much to Sandra. Thank you to Dr. Campbell. And we will see you folks back here for Conversations About Carbon in 2023.